Hi everyone. So today's lesson is kind of like a 4-day lesson. We're going to talk about it today, Wednesday, Thursday, and Friday. Remember that tomorrow is your quiz. So if you did not complete the quiz review over the weekend, then that's your homework tonight. This lesson should go by pretty quick. So you should have some time in class to either complete your quiz review or work on some problems again and study for it. But the homework that goes with this will be tomorrow night's homework so that it's done for Wednesday. Okay. The objective of today's lesson is to talk about what normal distribution looks like, as well as what the empirical rule is. Okay. So we're going to start by doing some vocab of some things that we probably already know, but just to do some review. So we've talked about standard deviation. It is the mean distance that every data point is from the mean of that data set. Standard deviation, which is this symbol, is a measure of how spread apart the numbers in a data set are. Okay, we use the word consistent usually to help with this. It says Jack and Jill are basketball players for their high school team. In their past 8 games, their total points have been recorded. So you got Jack's points here, and you got Jill's points here. Okay, it says which set of data has the lower and the higher standard deviation. So without going through and calculating it, we can kind of tell just based off of the numbers. If you notice, Jack's points go from 10, 11 to 12, 13 to 14. So his numbers are all pretty close to each other. Whereas if you look at Jill, she's got a 3, a 5, all the way up to 14. Her numbers are a lot more spread out. Okay, so because they're a lot more spread out, that means then hers would have the higher standard deviation. So Jack's would have the lower. So Jack, I'm going to say less spread out. Actually, I'm going to say more consistent. Okay, and then Jill's will have the higher standard deviation because hers is less consistent. Or you could also say spread out. Alright. Alright, so in this, we're actually going to find the standard deviation by hand, just so you can kind of see what the process is of where that's coming from. Made the numbers only 5 of them and smaller just so that it would be reasonable. So the first thing that you'd have to do when you find the standard deviation is find the mean of the set of data. Okay, so go ahead and do this with me. I'm just going to add up these numbers and divide by 5. Okay, so the mean is 8.8. Find the difference of the mean in each number. Okay, so that just means how far is each of these numbers from the mean. So if we do 4 minus 8.8, and it's okay if you leave these negative because we're actually going to square them in the next step anyways. Okay, so I'm just taking each of these numbers and subtracting the mean from it. So let's see, we get negative 3.8 and 0.2. And notice now they're going to flip to positive numbers. Okay. Alright, in the next part, we're going to square each of these results. So when we square, we get a positive number, so I'm just going to make them all positive. Alright. Hopefully this helps you appreciate the fact that the calculator can do this for you pretty easily. Okay. Next part, find the mean of the results. So now we're going to add up all these numbers and again divide by 5. And we get 18.66. 18.16. Okay, and then the last part says take the square root of that mean. So if we take the square root of it, this is where we get our standard deviation from. So our standard deviation is about, so this is our standard deviation, is about 4.26. Okay, so just an idea of kind of where that's coming from. Much better to have your calculator do it for you. I won't ask you to do it by hand again. Okay, so let's talk about what a normal curve is. So this is kind of the point of the lesson. So a normal curve, it looks like a symmetrical curve representing the normal distribution. Okay, so normal distribution. What it means is when you look at this, we have, if this right here is our middle, we have 50% of our data falls here, and then the other 50% of our data falls here. So normally distributed means that it's equal on both sides. Okay, it's a bell curve. Okay, a symmetrical distribution to the mean, its higher frequencies are in the intervals closer to the mean when graph data following normal distributions follows a normal curve. Okay, so what this means is that the intervals closer to the mean have higher frequencies, because if you notice, this right here is the tallest, which means that's your highest percentage, and then as you go this way, there's a lot lower percents here. Okay, the empirical rule is the 68, 95, 99.7 rule. So if you have something that's normally distributed, it will follow this rule, and it means that that's where the percentage of the points fall. Okay, so it says 68% of the points are within 1 standard deviation of the mean, 95% of the points are within 2 standard deviations of the mean, and 99.7, so almost all of the points are within 3 standard deviations of the mean. Okay, so remember, standard deviation is talking about how far things are on average. Okay, so what that looks like when we graph it is this. Notice that there's little points right here. So this right in the middle is our mean. Okay, and it's just the m that we use. Notice that there is 1 standard deviation to the left of it, and then this 1 tick mark to the right of it. Those are your standard deviations. So if you draw a line straight up and straight up, then that means all of this right here represents 68% of the data. Okay, so what that means is if I take this right here, and this would be my center, and that means 34% falls to the left of my mean, meaning less than my mean, and 34% falls to the right of my mean, meaning greater than my mean. Okay, so this would be my mean plus or minus 1 standard deviation. Okay, when we talk about 95%, that means then that here's my mean again, so it's always in the middle. There's 1 standard deviation, 2 standard deviations, 1 standard deviation, 2 standard deviations. So if I follow this straight up and this straight up, and then same with this, okay, that means that I have half of that 95% here and half of that 95% here. Okay, so if I take 95 and I divide it by 2, I get that 47.5% of my data points land here, and then the other 47.5% land above my mean. Okay, so this would be your mean plus or minus 2 standard deviations. Okay, so that's 95% of your data. That's almost all your data. You can see it's just this little bit that's left here and then here. Okay, now if I do it again with 99.7%, I start my middle, and then I go 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. And you can see that over here, it kind of looks like there's no data, but 0.3% means that there's very, very little data that could be over there. Okay, if I follow this up, everything that lies under this curve is half of that 99.7%. Okay, so if I take 99.7 divided by, divided by 2, so 49.5%, 49.85% of my data falls here, and then the other 49.85 falls here. Okay, so half above, half below. So this would be my my mean plus or minus 3 standard deviations. Okay, you can see hopefully that as we go out more standard deviations, we're getting further from the mean, which is why we're collecting more or a bigger percent of our data. Okay, so now let's kind of flip this over, and now we're going to apply this. Okay, so it says the temperatures in a carefully controlled room are normally distributed. So we will talk about when things are not normally distributed, so you have to be told which one. Throughout the day, the temperatures have a mean of 32 degrees and a standard deviation of 1.8. So here's my mean, 32 degrees. And then my standard deviation is 1.8. Okay, so Shane randomly selects a time of day to enter the room. What is the probability? Notice probability, that means we need a percent. So we need to create a fraction. What is the probability that the temperature will be between 30.2 degrees and 33.8 degrees? Okay, so what we do is we start by saying this is my mean, which I know is 32. Okay, and then my standard deviation, each of these tick marks represent one standard deviation. So that means that I'm going to go plus and minus 1.8. So if I add 1.8 to this, that would put me here, and that would give me 33.8. Okay, I'm going to do that again. So 33.8 plus 1.8 puts me at 35.6. I'm going to have to write kind of small. And then add 1.8 again. And 37.4. Okay, now I'm going to go the other direction and subtract. So 32 minus 1.8 minus 1.8. Alright, so 30.2 and 28.4. Okay, so now, if we look at what the question was asking for, it said, what is the probability that the temperature will be between 30.2 and 33.8? So notice that 30.2 is right here, and 33.8 is right here. We're going to focus on really making sure that the numbers are hitting at nice places with this. Okay, so notice that if this is my mean right here, that we went to the left one standard deviation and we went to the right one standard deviation. Because we went right and left one standard deviation, so I'm going to say plus or minus 1 standard deviation, then that means that the probability would be 68%. Okay, because if you think back to the other side, when we were within 1 standard deviation, it was 68% of that data falls there. Okay. What is the probability that the temperature will be between 28.4 and 35.6? So this would be my mean right here at 32. Okay, this would be 30.2. This would be 28.4. Going the other direction, this would be my 33.8. And my 35.6. I'm going to stop there since those are the numbers that I need. So here's my 28.4. Here's my 35.6. Here's my middle. Okay, notice that right here is 2 standard deviations to the left, and here is 2 standard deviations to the right. So that means, since this is plus or minus 2 standard deviations, following our rule from the other side, that means that 95% of my data falls there. So there's a 95% chance that if he randomly selects a time of day, the temperature will be between those temperatures. Okay, let's try again. The birth weight of children at Cherishing Hills Hospital is normally distributed, and everything that we do today will be normally distributed, with a mean weight of 7.3. So 7.3. And a standard deviation of 1.7 pounds. Okay, what percent of newborns at the hospital had birth weights between 3.9 and 10.7 pounds? Okay, so we want to start by labeling what we know. So we know that the mean birth weight is 7.3, and then we know our standard deviation is 1.7. So we can take 7.3 and add 1.7. Okay, so this is my 9. This is my 10.7. I'm going to go all the way to the edge. So 12.4. Okay, and then I need to go the other way. So 7.3 minus 1.7. Alright, so 5.6, 3.9, and 2.2. Okay, so I want to know what the percentage is that it falls between those weights. Okay, so between 3.9, so that would be here, and 10.7, which would be here. Here's my middle. Okay, notice that this is 2 standard deviations to the left, and this is also 2 standard deviations to the left. So since it is plus or minus 2 standard deviations, that would mean the probability would be a 95% chance. Alright, great, let's try again. So in this one, again, we know that the mean is 7.3. We want to know the percent of newborns who have a weight between 2.2 and 12.4. So I'm going to use my numbers from over here. I know that that's 2.2. And then I know that 12.4 is all the way over here. Okay, which means that we're going through the whole thing, almost. So since we're going from here all the way to here, so that's 3 standard deviations to the left, because we go 1, 2, 3, and then 3 to the right, 1, 2, 3. So since it is plus or minus 3 standard deviations, that would mean that this represents 99.7% of our data. So almost every newborn is between 2.2 and 12.4 pounds. Okay? Alright, 2 more. The scores of a particular college admission test are normally distributed with a mean score of 30 and a standard deviation of 2. So mean score of 30 and a standard deviation of 2. Okay, Aaron scored a 34 on his test. What percent of test takers did Aaron outperform? Okay, so that's the big question there. Alright, so we know that the mean is 30. Standard deviation is 2, so this is 32. This is 34, which makes this 36. Okay, and then this would be 28, 26, and 24. Okay, so here's the middle. Alright, Aaron scored a 34. So if Aaron scored a 34, that means he's right here. It says what percent of test takers did he outperform? He outperformed everybody here, as well as everybody to the left side of the mean. Okay, so here's how we figure this out. From here all the way to the end has to represent 50% of our data. Okay, because if this is the middle, then 50% falls to the left and 50% falls to the right. Okay, notice that Aaron is right here, which means then that's two standard deviations away from the mean. So if you think back to the front side here, notice this was 2 standard deviations. So when it's 2 standard deviations, it means 47.5% fall to the left and 47.5% fall to the right. Okay, so that means then that this right here represents 47.5%. So then Aaron outperformed 50% and 47.5%. So if we add that together, we get 97.5%. So notice it wasn't symmetrical on both sides of the mean, so we had to do a little bit of addition. Okay, let's try again. So we know that the average is 30. Okay, go ahead and just write in all of your numbers again. Okay, so in this one, it says Sally scored a 28. So Sally's right here. What percent of test takers did Sally outperform? Okay, so here's my middle. So Sally outperformed everybody that falls here. So then what we can do is we can figure out what falls here. Okay, so here's what we know. From here all the way to the end has to represent 50% of our data because that's the upper half. Okay, and then from here to here, so from here to here then is one standard deviation over. So if we think about one standard deviation, again if we look back at here, notice that going plus or minus one standard deviation took 68% and cut it in half. So that meant 34 was to the left, 34 was to the right. So now when we look back at this, since this is one standard deviation to the left, oops, oh my goodness, this would represent 34%. Okay, so if Sally scored a 28, then this is the percent she didn't outperform. So we can take 100% and we can subtract 34 and 50 to get what's left. So that makes 84. So that means that she outperformed 16% of the test takers, which represents all of this. Okay, so it should make sense that it's less than 50%. Okay, so then that would be our answer. Okay, so let's try again. Last one. The birth weight of children born at Rolling Hills Hospital is normally distributed with a mean weight of 8.5 pounds and a standard deviation of 1.2 pounds. Alright, so before I'm reading this, I'm going to go ahead and fill in my normal curve. So this would be 8.5. Alright, so we have 8.5 plus. So go ahead and fill out yours. And then double check to make sure your numbers match mine. This should be 9.7 and 10.9 and 12.1. Okay, going the other way. This would be 7.3, 6.1, and 4.9. Okay. So, what percent, so again, we're looking for that percent, what percent of newborns at the hospital had birth weights of more than 9.7 pounds? So looking at more than 9.7 pounds. Okay, well this right here is my middle, and then this is where 9.7 is. Okay, so I want to know what falls here, because this would be greater than 9.7. Okay, so when you do this, you want to shade what we're trying to find. Should help. Okay, so this is one standard deviation to the right, so that means from here to here represents 34%. Okay, because remember, one standard deviation left and right is 68, so we cut it in half. So that represents 34%. So that means then from here all the way to the end, this has to total 50%. So then this would have to be 16%. Okay, it's got to be 50% because from the middle you'll always have 50% fall left and 50% fall right. So 16% of newborns would weigh more than 9.7 pounds. Okay, let's try the next one. Go ahead and fill your numbers in. Double check that they're obviously the same as the left side. Okay, so the last one. This one says, what percent of newborns at the hospital had birth weights between 7.3 and 12.1? So again, I'm going to find my middle. 7.3 would be here, and 12.1 would be here. Alright, now, if this didn't say 12.1, but it said like 14 or something, then it would be going all the way to the edge, and then that would be 50% of my data. Okay, however, it's not going all the way to the edge, it's going to here. So this means that it's 3 standard deviations over. Okay, if you remember from the front side or need to take a look at it, 3 standard deviations to the right and the left represented 99.7% of my data, which means then if I cut this in half, that's what is being represented, 3 to the left and 3 to the right. Okay, so if I take 99.7 and I divide by 2, I get that this is 49.85%. So very close to 50%. Okay, so this is 49.85%, and again, it's because it stopped on that third standard deviation. If we go one to the left, one left and one right is that 68%, which then we divide by 2, making this 34%. Okay, so that means that I would take 34 plus 49.85, and then that would tell me how much is between 7.3 and 12.1 pounds. So this would be 83.85% of babies. Okay, so as you go through your homework and you're kind of trying to make sense of this, the big thing is focusing on that empirical rule. So I'm going to flip back to this real quick. So focusing on this empirical rule down here that says this is 1 standard deviation left and right, this is 2 standard deviations left and right, and this is 3 standard deviations left and right. Okay, so knowing that then allows you to say, well, if I went left 1, that's 60%, which gets cut in half. Over here, if I went left 2 standard deviations, that's 95%, which got cut in half to make 47.5, 47.5. If I go 3 standard deviations to the left and to the right, then that represents 99% of my data. Cut that in half, and it's 49.85 on each side. Okay? I will be back tomorrow, so if you guys have any questions, feel free to come in and see me in the morning. But remember, your quiz is tomorrow, so make sure that your quiz review is done, and then this will be your homework, or this right here, I guess, sorry. This worksheet, day 1, will be your homework for Tuesday night. Okay? All right, thank you.